Okay, so another example to do with vertical motion under gravity. We've got a particle projected vertically upwards from a point O with speed u meters per second. The greatest height reached by the particle is 62.5 meters above O. We're going to find the value of u and the total of time for which the particle is 50 meters or more above O. Okay, so what's going to go on in this question then is that we've got a particle starting from this point O. It goes up and comes down at some point. We're told that the greatest height is 62.5 meters. Let's make a note of that there. We're going to work out at some point that when it's 50 meters above the ground. That's going to be relevant later. We know we're trying to find u rather, which is going to go up here. We've also got the acceleration, which is going to be down here at 9.8 meters per second squared, or minus because it's going downwards. We'll sort of start working things out from there. So in part A, the greatest height is 62.5 meters. It's already saying that S is 62.5 meters. At that point, the velocity will be 0 because at the top you basically stopped because you're turning around to come back down. So 0 meters per second. Acceleration is minus 9.8 meters per second squared. U is the kind of thing that we're trying to work out. So the equation that connects those is v squared equals u squared plus 2as. We can substitute things in. So 0 squared is equal to u squared plus 2 times minus 9.8, so minus 19.6 times s, which is 62.5. So therefore u squared is equal to 1225, and so u will be the square root of that, which is 35 meters per second. Okay, so the next part, find the time for which the particle is 50 meters or more above O. So in part B, we're starting with u being 35 meters per second there, because that's what we've calculated. It starts at here. The acceleration, as always, is minus 9.8 meters per second squared. We're talking about height of 50 meters. So that's a displacement of 50 meters above the ground, and we want to find the time. So we're going to find the time at which is at this point and at this point, and then the time above there is just finding the difference between the two. Okay, so the equation that connects those is S equals ut add a half at squared. So we can substitute the values we've written here into that equation. So 50 is equal to 35t minus 4.9t squared, or 4.9t squared, take 35t, add 50 equals 0. So we have a quadratic equation, and then we can solve that using any method we wish. That gives us two solutions, so it gives us t is 5.1686, or the other solution is 1.9742. So basically we're saying that at this point that's taken 1.9742 seconds to get to there. We go up here, and then after 5.1686 seconds we're now coming back down past that point. So the time above 50 meters is 5.1686 subtract 1.9742, and we can just calculate that to get the answer, which comes to 3.19 seconds to three significant figures.